everybody, and welcome to the third episode of the SenoTalk. The third one is a charm, and so I've invited Hannah one more time into the studio to talk about our technology and the questions we have been asked by our customers in the past few months. Let's see if Hannah has already joined us in the studio. Hannah, are you there? How are you?
Hi Valerie, I'm well, thank you, and I hope you're fine too. It's great to be back again, and as you said, the third time is a charm, so I'm very looking forward to today's episode. You mentioned that today we are talking about the technology. Do you mean capabilities, requirements, limitations and such?
Yes, that is exactly what I meant. Maybe we can start with a very generic question. Can you tell me a little bit more about the limitations of our technology? We always talk about the possibilities, but are there any materials that can't be measured with material sensing?
There are indeed. So even though NIR spectroscopy is a very powerful technique, there are certain limitations. For example, too low concentrations are hard to measure, like gases or steam, and also bacteria and virus loads. In the field of textiles, it is currently not possible to measure materials levels of less than 1%. So for example, if a textile contains less than 1% of silk, we wouldn't be able to detect the silk at this stage. Another material class that is difficult to detect are metals. Most metals reflect light in the near-infrared range without having a characteristic fingerprint. That means that it isn't possible to differentiate between copper, gold and iron, as they look totally the same through the lens of NIR spectroscopy.
Thanks for the detailed information, Hannah. And how about capabilities on the other hand? Which materials can be analyzed with material sensing?
NIR spectroscopy, which is the basis of material sensing, is a very versatile technique. For example, you can measure the moisture content in grains, the composition of textiles, or detect stains on a broad range of floor materials. All these materials are composed of a molecular structure. That means that certain atoms are linked by a chemical bond, and this bond can be measured with NIR spectroscopy.
Okay, and could you maybe say a few more words about how these capabilities can be utilized in real life? So, for example, how could a facility, maybe a fiber manufacturer, benefit from those capabilities?
A lot of customers are wondering whether this is just another lab device. The answer is it's not. It's very lightweight and small, so just take it to the place where you want to take your measurements. For example, directly into your production hall or to your warehouse. All you need is an internet connection and a smartphone or laptop to access the software. So if, for example, you are producing yarn, you don't have to collect samples and give them to the lab. You can analyze the yarn right where it is produced. To give you a better idea of the difference between our handheld device and an ordinary spectrometer, I quickly take you to our lab. As you can see, our handheld device is way smaller than an ordinary lab spectrometer. In addition to that, you can just take it to your pocket and measure wherever you want.
Thanks, Hannah, for the detailed information and for even showing us the lab spectrometer. That was really interesting. I personally think that the benefits that material sensing brings for fiber producers is a great example in how it can benefit many, many other industries. So let's maybe dive a little bit deeper. How can it make quality testing more efficient? So within production processes, without having to rely on time-consuming methods or bulky items like spectrometers.
When we talk about how our technology makes testing more efficient, we mostly talk about two factors, time and destruction, or better, time and non-destruction. As I have mentioned before, you can measure your materials mobile, wherever you are, and receive the results instantly. That saves you time, and as you don't have to collect samples and send them to the lab, and neither do you have to wait to receive the results. You also save resources, as the samples don't get destroyed when using our technology. Testing methods in the lab usually lead to the destruction of samples, meaning they can't be used anymore once the analysis is done. Depending on the use case, this can be an expensive process, as a great number of samples would be destroyed.
So really, you save time, money, and resources. Not just one, but 3 good reasons to consider changing to material sensing. I would say maybe let's do one more question to sum this up. What is important to produce reliable results?
That's a very good question. When you use the SenoCorder Solid, you don't actually have to take much into account to create reliable result. The only thing you have to make sure is that the measurement window of the SenoCorder Solid is placed correctly on your sample before you start the measurement. The sample should also be laid out evenly to avoid wrinkles and bumps. The rest is all done for you prior by our team. We use chemometrics to develop and train chemometric models. Once they are created, they are the basis for the results you receive when measuring samples. They need to be trained very well in order for those results to be exact and reliable. You can learn more about this if you check out our blog. There is a whole article about the development of chemometric models and how they are applied.
And with that, our 3rd episode of the SenoTalk is already coming to an end. Thank you so much for your time, Hannah, and thanks everybody for watching. Make sure to check out the blog post on chemometric models. I will link you the blog underneath the video. And make sure to subscribe to our channel so that you don't miss out on any new videos or any new episodes of the SenoTalk. I will see you next time. Have a good day.
It was fun to talk to you again, Valerie. I am already looking forward to the next episode. Bye!